This is Elliot Haspel, and welcome to another edition of Best Practices Weekly. Today we're going to be talking about conquering subtraction with regrouping, every teacher's favorite part of math. And this comes from an article in Teaching Children Mathematics, in which a veteran math teacher talks about a whole bunch of strategies for helping students with subtraction with regrouping, which is not just an issue for younger students, which, as many teachers know, can become an issue for students as old as 5th or 6th grade even can still struggle with this idea. And so the teacher talks about a bunch of different strategies. I'm just going to go through each of them and talk about them and give some examples. But the key kind of overarching idea here is that there's a balance of strategies, and all told, when you put them all together, they balance both teaching the idea of subtraction with regrouping conceptually, and then also really helping students master the skills themselves. And so these are in no particular order. First is start with number sets. So the basic idea is if students don't understand what subtraction even is or what addition is, then they're going to have a whole lot of trouble, research has shown, really conquering and really dealing with the actual strategies themselves. And so one of the pieces here is to be very careful to not use too many rules. So for example, telling students you never subtract a larger number from a smaller number, you just can't do that, is actually very confusing for students, both because it doesn't help them understand why, and second, later on in their academic careers when they start getting the negative numbers, it's obviously not the case, and that can be very, very confusing for students. Next, work from the concrete to the abstract. So start with manipulatives, start with physical representations of numbers, and then move to the point where you're just giving them a numerical problem, like 23, minus 17. And so number lines can be really powerful here, helping students see, like, hey, if I mark the 17 here, if I mark the 9 here, and I figure out what's between them, that's what subtraction is. So start with the concrete and the manipulatives, the number lines, then move to the abstract. Use fact families. In case you don't know what that is, a fact family is showing the different relationships between numbers. So example, 8 plus 9 equals 17, 17 minus 9 equals 8. This is key so students both can understand that the subtraction is not some random out there thing that they do. It's actually very much tied to addition, which many students are much more comfortable with. It also starts to lay the basis for some basic algebraic thinking, this idea that actually there's connection between two different kinds of problems, that they're actually solved in similar ways. And going right along with both of those pieces is this idea of varying the unknowns placement. So students, especially elementary school students, get this idea that all we ever do when we add or subtract is we're trying to figure out the unknown term that goes to the right of the equal sign. So again, 17 minus 9 equals question mark, some number, but we're trying to figure out that. That's actually not, of course, always the case, and so by varying the unknowns placement, by helping them find a different kind of number, we actually help students see both what subtraction is all about, again, builds that idea of sort of facility with algebraic thinking, facility with understanding how to manipulate numbers. So try, for example, 8 plus question mark equals 17. Most students can actually figure that out pretty quickly, or similar ones. If it was 8 plus 4 equals, 8 plus question mark equals 12, for example, they can pretty easily figure out that's 4. They might, though, not actually know why they know that, and so as teachers, if we help guide them to understanding, you actually just subtracted in your head. You didn't realize it, but in this case, you're doing 8 plus question mark equals 17. You just did 17 minus 8 to figure that out, that it's 9 in that situation. They were actually helping students really build up their conceptual knowledge. Next, reinforce place value concepts. So there's a researcher that the author here quotes who says that really understanding the elements of the base 10 system is a critical element of math. And so in this case, for example, students need to understand that numbers the way we do when we're doing regrouping, we're not changing the values of numbers. We're just actually changing the way that we're naming them. And so, for example, 63, it can be called 6 tens and 3 ones. It's also 5 tens and 13 ones. There actually isn't a value difference there, but there is obviously a difference in how we're naming them and what we can then do once we name them differently, but really helping students understand the idea of base 10, the idea of place value there. That can often be a core misunderstanding that makes it very, very difficult for students to know what to do with regrouping. Next, money is motivating. This is a very simple sort of idea that if you want to help invest students, if you want to make it very meaningful to them and therefore help them be invested in and retain the information, often using money can be a very easy way to do some subtraction because the numbers work out well. You can do the physical, actual coins, things like that. Regrouping help is something the author sort of titles this part of her article, and what it means is that students can often, once they've got the hang of regrouping, think that you have to regroup all the time. You have to regroup every single number, which obviously isn't the case. And so to figure out which numbers need to be regrouped, which numbers need help, a suggestion here is have students actually physically become the numbers. So have each student hold up a little sign with a different digit, for example, and create a subtraction problem. 3 students, if you're doing a 3-digit number, standing up, the minus sign being 1 student, and then 3 students kind of kneeling down. You've got the number. And then you have a couple of students holding signs that say help, and then have the class figure out what digits need that help, what digits need to be regrouped, and why. Again, just to get them in the habit of thinking very much like some digits do need regrouping, some don't. Think about the instructional timeline. So oftentimes teachers can jump very quickly to the idea of doing some drilling on problems, or they can spend too much time sometimes on the conceptual and forget to get to giving students a whole lot of time to practice once they've mastered pieces of this. So thinking very strategically about, have I given students enough time to do both? Practice conceptually and practice in the actual skill? Am I asking them to just show me what they know in different ways? I ask students to create their own word problem which involves subtraction with regrouping, for example. Things like that. Am I using the different levels of Bloom's taxonomy? And am I doing it in a proper order? Then go beyond the book. So this is sort of a call to think about other instructional resources, websites, if you have a Prometheum or Smartboard in your classroom, just using other kind of methods that can go beyond just what's in the textbooks. One website that the author mentioned specifically is mathplayground.com, which she says has a good video on subtraction with regrouping and some games around that. So that could be one to check out. And then, lastly, identify common errors. So there are 2 which a researcher has pulled out, which the author talks about as being very, very common when it comes to subtraction with regrouping. The first is students trying to subtract smaller numbers from bigger numbers regardless of placement. So they'll see a smaller number on the bottom, they'll see a bigger number on the top. It doesn't matter if they're lined up, it doesn't matter if there's the regrouping sign, it doesn't matter what's going on. That's smaller, that's bigger, that means I can subtract them, and then they just do it. And then it gets all out of order. And second, regrouping from a 0 digit. So what do you do if the next number over is a 0 when you need to regroup? That can be one of the most difficult and most common errors. When you know these are common errors, you can front load them in your teaching, make sure that you're helping students see them, know that they're common errors, and avoid them. So again, these are a whole bunch of strategies to help students conquer this idea of subtraction with regrouping. There are a lot more out there, of course, but definitely hope that this is helpful as you think about helping students with this thorny topic. So thanks for watching and happy teaching.